Hi guys, welcome to my YouTube channel Tech Chips. Please subscribe to get latest video updates. In this video we are going to talk about solid design principles. Here are the 5 solid design principles. S stands for Single Responsibility Principle (SRP). O stands for Open-Closed Principle (OSP). L stands for Liskov Substitution Principle (LSP). I stands for Interface Segregation Principle (ISP). D stands for Dependency Inversion Principle (DIP). Now let's discussing about each one of these. First one is Single Responsibility Principle (SRP). So what is SRP, Single Responsibility Principle? Well, when you create a class in your system in such a manner that when your systems runs, this class will have only tasks to perform. There will be other classes to handle other tasks. For example, there can be a class which do tax calculations only, and then there is another class which do billing work. And that is true for the whole system. In your system there should be no other place, basically a class where these functions are performed. So having a system in such a manner is called to have used Single Responsibility Principle. Now let's talk about the benefits of SRP. When a class has only a single responsibility, it is likely to be very robust, which is good for your system. The another benefit of single responsibility is that when classes, modules or components have single responsibility, these become easy to maintain, easy to understand for everyone, and are also easy to implement. Next solid principle is Open-Closed Principle (OCP). Open and closed principle means that a class is open for extension and closed for modifications. Bertrand Meyer is generally credited for having originated the definition of open-closed principle in his book Object-Oriented Software Construction. Let's take an example of bank accounts like regular savings, salary saving, corporate etc. for different customers. As for each customer type, there are different rules and different interest rates. The code below violates OCP principle if the bank introduces a new account type. Said code modifies this method for adding a new account type. So in this way the classes are open for change, but only change of extent on only, not by modifying the base classes or interfaces. Next solid principle is Liskov Substitution Principle (LSP). If any module is using a base class, then the reference to that base class can be replaced with a derived class without affecting the functionality of the module. Let's say our system wants to calculate discounts for inquiries. Now inquiries are not actual customers, they are just leads. Because they are just leads, we do not want to save them to database for now. So we create a new class called as inquiry, which inherits from the customer class. We provide some discounts to the inquiry so that they can be converted to actual customers, and we override the add method with an exception so that no one can add an inquiry to the database. This was one very good example of Liskov Substitution Principle. Next solid principle is Interface Segregation Principle (ISP). By segregation of interfaces we mean that we create more than one interface out of one big interface or base class. That way each interface deals with one specific type of behavior of the system. As an example, consider that the toy interface is modified to include a walk method to accommodate toy robots. As a result, you now need to modify all existing toy implementation classes to include a walk method even if the toys don't walk. In fact, the toy implementation classes will never be closed for modifications, which will lead to a fragile application that is difficult and expensive to maintain. This is a violation of the interface segregation principle. Such violations affect code readability and confuse programmers. Violation of the interface segregation principle also leads to violation of the complementary open-closed principle. And the last one is Dependency Inversion Principle (DIP). The core purpose of Dependency Inversion Principle abstractions should not depend on details. Details should depend on abstractions. Let's say you have a class which depends on another class to perform some action. In that case the dependent class will require the instance object of the class on which it depends. For that, what can be done is you can provide the instance of dependency to the dependent class while the dependent class is being initialized. We also have inversion of control, which also comes into the picture. The inversion of control pattern can be implemented in several ways. The dependency injection pattern and the service locator pattern are specialized versions of this pattern that delineate different implementations. So this was the detailed explanation of solid. In my next video I am going to explain all these principles by code examples. Please comment your views about the video. And subscribe to get more similar video on my channel. Thank you for watching this video.